2.2 Linear Equations. Don't forget to write in the section title up here every time we start a new section. Linear equations. It's an equation whose graph is a blank. In order to realize what that word is, you need to look back at the vocabulary word right here, linear equation. And the word linear means anything that forms a line. That's the base word right there. So an equation whose graph makes a line. There's a standard form we have for writing linear equations. You've seen it before, and it looks like this. Capital AX plus capital BY equals C. A, B, and C are real numbers. Usually with standard form, the first number is not negative. We make that one positive. Also, we try to write it without fractions. We try to make it in whole numbers. That's what makes it look like standard form. These are examples of linear equations. You can look that over. These are examples of non-linear equations. These would be curves and parabolas and things like that. Look at the difference between linear equations and non-linear equations. Tomorrow in class I'm going to ask you what's the difference between these two. I want to see if you can figure it out. So looking at these examples, we have to take this equation and write it in simplified standard form. So we're looking for capital A X, some number in front of the X, plus capital BY equals C. And we want to have no fractions or decimals in it. We want whole numbers, X and Y, to be on the left. The one that has no variable goes on the right. So in this case, the one that's in the wrong place is this one, because we want X and Y to both be on the left. So what I'm going to do is just simply try to get my X over here on this side. So I'm going to do plus 5X on both sides, plus 5X. And we usually want to write the X term first and the Y term second. So I'm going to say 5X plus positive Y, so just plus Y, equals, this one canceled, so it equals 6. And that's standard form, where A is 5, B, what's in front of the Y right there? It's a 1. And C, the one on the right side with no variables attached to it, the constant, is 6. In letter B, there's two problems. We have a fraction, which we don't want in standard form, and we have the Y on the wrong side. So the first thing I'm going to do is eliminate the fraction. And to do that, I'm going to multiply everything by the denominator. Multiply everything by 7, just like we did in the previous chapter. This times 7, this times 7, and this times 7. So if I multiply 2 over 7 times 7, I'm left with 2x equals. Then I have 7 times 2y, so that's 14y. And then I have 7 times 5, that's 35. So I got rid of the fraction part, but I still need to make it look like standard form. So I need to move my y over, so x and y will both be on the left-hand side. So I simply do that by minus 14x on both, minus 14y on both sides. So over here, they don't go together, they're not like terms. So I just write it as 2x minus 14y. You just have to rewrite it so that x and y are on the left-hand side, and your constant, the one with no variable, is on the right-hand side. In this case, capital A would be 2, capital B would be negative 14, and capital C would be 35. Now look at letter C. 5x minus 10y equals 25. It looks like it could already be standard form, and it is one of the forms of standard form, but if you want to make it simplified, you should reduce if you can. See if there's anything that you could actually divide everything by. And I see a greatest common factor of 5. And I can go ahead and divide or reduce everything by 5. You can write it like this, as long as you do the same thing to both sides. So what we have is 5x over 5 minus 10y over 5, and some of you can go ahead and do that in your head, equals 25 over 5. And we can turn that into, the 5's can cancel. You have x minus 10 over 5 is 2. And then you still have the y equals 25 over 5, or 5. And in this case, the capital A would be a 1. The capital B would be negative 2. And the capital C would be 5. A linear function, again, forms a line. A function is linear if it can be written in this form as well. F of x equals mx plus b. Now that one you probably recognize from years past, mx plus b. See if you can remember before I tell you. What does the m in this equation stand for? Hopefully you said slope. M is the slope. The number in front of the x stands for the slope. And the b, do you remember what that one stands for? That one is the y-intercept, where that particular line crosses the y-axis. Here's another term for you. If m equals 0, and if you look at it here, if m equals 0, then this entire term is just gone. It's 0. So you're left with the f of x equals b, right here. And that's going to be a horizontal line, or a constant function, where the slope is 0, it's a flat line. Horizontal, of course, looks like this, a horizontal line. Sometimes called a constant function. And here's another one for you, x and y intercepts. The x and y intercept is where the line crosses or touches the x-axis or the y-axis. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. And we're going to use those right now. Graph the x and the y-intercepts, and then once we do those points, we can then graph the line. So what you need to do is find the x-intercept and the y-intercept, and you need to do that separately. The x-intercept we're going to have to find, and then the y-intercept. And these actually are really easy if you remember one thing. The x-intercept, the only thing you care about is where that line is touching the x-axis. So we're basically going to just ignore the y. So what I'm going to do is completely cover up the y, and I'm only going to concern myself with the x. 5x equals 15. That one's easy to solve. The x-intercept would be 3. Divide both sides by 5. So we're going to go to the x-intercept 1, 2, 3, and that's the point where that line will cross the x-axis. For the y-intercept, it's the same idea, except all I really care about is the y. I cover up the x and I don't worry about that, and I try to figure out the y-intercept would be. If you divide both sides by -3, then you will have -5. And that is down here, 1, 2, 3, 4, 5. You go on the y-axis and you see where the y-intercept would be, and it's negative, so you go down 1, 2, 3, 4, 5. And now you can see your line right there. Your line just connects those 2 points. And there you have it. Let's try this next one together. First thing we have to do is figure out the x-intercept and the y-intercept. So the x-intercept is only where we care about the x-axis, and the y-intercept is where we care only about the y-axis. So for the x-intercept, just ignore the y completely. 5x equals 10. So we would have x-intercept is at 2. Divide both sides by 5. And for the y-intercept, you ignore the x and you figure this out. 2y, it's positive. 2y equals 10. So if you divide both sides by 2, the y-intercept would have to be 5. So all that's left to do is graph those 2 points. The x-intercept goes on the x-axis, and it's at positive 2. The y-intercept goes on the y-axis, but this time it's positive 5. 1, 2, 3, 4, 5. And you graph the line that goes between those 2 points. And there you have it. So go ahead and turn to the back side. I'd like you to try 1, 2, and 3. Hit pause. Try these problems on your own, trying to put them in standard form, getting rid of fractions and moving the x and the y both to the left-hand side, and the constant with no variable on the right-hand side. And also remember, try to make the front number positive. Don't let it be negative. When you're done trying these, go ahead and hit play again to check your answers. Okay, so check your answers here, see if you got them right. Look over my work that I did to see if you understand it. And if you have any questions about it, we'll go over it tomorrow in class. I'll give you a chance to ask any questions you had on this video.